Hi class, this is a PowerPoint presentation discussing dynamics, and this is for your class Physics for Engineers. Dynamics is a branch of mechanics which studies the causes of motion, including force and momentum. While force is a push or a pull, and the unit of measurement we use is Newton or the big letter N. So we have two types of forces, contact forces and non-contact forces. For contact forces, these are forces experienced by bodies when they are in physical contact with each other. You see here the example muscular and frictional force. Muscular are the applied force because these people are pushing the box, so they're applying a certain kind of force, and that's contact force. In this one naman, frictional force, it's the force opposing the direction of the motion. So in this case, the box is going to the right, but it has a frictional force going to the left. So there. And then we have another kind of force that is non-contact force. These are forces experienced by bodies even if they are not in physical contact with each other. For example, magnetic force, electrostatic force, and gravitational force. They work even though they don't have any physical contact. So these are the other types of forces. For contact force, we have frictional force, applied force, air resistance, normal force, or the force perpendicular to any surface, spring force, of course, brought about by spring, tension force from ropes and strings, and buoyant force from the surface of the water. And we have, on the other hand, non-contact forces. We have gravitational force, magnetic force, electrostatic force, and nuclear or radiative force. Net force and equilibrium are two important terms that you need to learn for dynamics. Net force is the sum of all forces acting on an object. So you see here, this is the object. For example, it's a book on the table. So we have four forces acting on it. First is the normal force. It's the perpendicular force from the surface of the table. The table is exerting a perpendicular force to the book. So that's the normal force. And in return, the force of gravity is pulling it downwards. So we have two forces, opposite forces in the y-axis, but it's not moving in the y-axis because apparently they're equal. So if the gravitational force is, let's say, 100 newtons, the normal force is also 100 newtons. Therefore, it's not moving vertically. Now let's go to the horizontal forces. We have the applied force. Oh no, that this could be air force or the air resistance because there's air blowing the book. Even though it's too weak, it's still blowing the book. But it's not moving because there is a frictional force on the opposite side, which in return opposes the air force. So in that case, it's not moving horizontally because it's balanced. Okay. And then, if everything is in balance, it means it is in mechanical equilibrium when the net force is zero. Like just like here in this example. Okay. Here are some examples showing you the free body diagrams of some objects in motion and not in motion. For example, this is a rocket accelerating upwards. So in this diagram, the force going up is the thrust, and the force pulling it downwards is the drag together with its weight. The second example is a boat floating in the water, so it is experiencing buoyant force, pushing it upward, and its weight pulling it downwards. The third is a person bungee jumping. At the bottom of a bungee jump, where the person is stationary, the weight is downwards, and then you have the tension force in the string. Last is a person rappelling down the wall of a building with a rope. So this is the tension force, and you have the weight, and you also have the friction on the feet of the person, and also you have that normal force from the wall towards the feet of the person. So you see in this example, it's complex. It has a lot of forces acting on it. So there. So for the net force, we have two kinds of forces. First is the balance force, and next is the unbalanced force. If there is a balance force, meaning the net force is zero, it could be moving with constant speed or it could be at rest. Then for unbalanced forces, meaning when you add everything, all the forces, it will not be equal to zero, meaning the object is in motion. So for example, here in this one, it is balanced, so this brick is not moving. However, this brick here, it's not moving vertically, but it's moving horizontally because we have here an excess force in the x-axis. So how do we determine the net force? For example, here in this first example, um, upwards it's 200, south it's 100, meaning it will move vertically. Where? To the north. Because that's 200 minus 100, may matitirang 100 upwards. And also here, horizontally, 100 here and 350 here. So that will be 250 because that's 350 minus 100. May matitira kang 250. Saan papunta? To the right. Next, ito naman. Saan kaya papunta ito? Gagalaw ba to? Yes, gagalaw siya. Saan papunta? Sa left. Kasi 500 minus 200, that will be 300. So, nasan yung 300 dito? So, ibig sabihin dito gagalaw yung box. Next naman ito. Gagalaw ba siya? Gagalaw siya vertically? Yes, gagalaw siya vertically. 50 newtons to the north. Eh, horizontally, gagalaw ba siya? Hindi siya gagalaw dahil they're both 200. So, 200 minus 200 is 0. So, hindi siya gagalaw horizontally. This one, gagalaw siya vertically upward, 50 newtons. Gagalaw din siya ng leftward, 200 newtons. This example, gagalaw. Yes, gagalaw siya to the east and south. How about this? Gagalaw ba siya? Gagalaw siya to the north and gagalaw din siya to the east with 100 newtons to the east. Yan. Ito naman, this one, your net force is 0. Ito naman, this one, your net force is 20 newtons because they are in the same direction. When they're in the same direction, you add them. So that's 20. But if they're in the opposite direction, you subtract. So that's 10 minus 8, that will be 2 newtons. So there are three laws of motion by Isaac Newton. The first law states that a body at rest will remain at rest and a body in motion will remain in motion unless acted upon by an external force. Second, the force acting on an object is equal to the mass of that object times its acceleration, or force equal to ma. And then your third law is for every action there is an equal but opposite reaction. Newton's first law is inertia. It says that an object will remain at rest or in uniform motion unless an unbalanced force acts upon it. So here we'll see an example. Seems obvious but deserves a little analysis. For example, these beer bottles, this one, the force of gravity pulling them down, but they don't move because the tabletop is pushing up at the same time. So that's the normal force with an exactly equal and opposite force. The overall force is 0. There. Next, even though this truck is being pushed hard, it is not moving because friction is acting there. the forces are balanced, so they're not moving. Well, here, the freewheeling cyclist will only stop if friction brings her to a halt or stop, which on Earth it always will. And then, an astronaut for any other object in deep space a long way from any large masses and gravitational fields will experience no force. Wala kasing air doon. So, nothing will give it air resistance. So, there's no force to act on it. Once moving, the object will move at the same speed forever unless another force comes into play. However, if an unbalanced force acts, as with this rocket, where the thrust of the rocket is far greater than friction, the object accelerates. This leads to the second law of motion. So here we have another example for the first law of motion. So it says an object at rest will remain at rest unless there will be a force acting on it. And it will continue in motion unless, again, there's another force acting on it. Okay? So, ang isang bagay, hindi gagalaw kung walang puwersang gagalaw doon. At yung isang bagay, hindi rin titigil ng paggalaw unless may pipigil sa kanya. So, that's the first law of motion. Another example here, the bus moves suddenly, the passenger jerk backward. So, kapag biglang gumalaw yung jeep, ikaw ay parang backwards kasi yung jeep pa lang ang gumagalaw. Ikaw ay stationary pa lang. So, yun yung inertia mo. Kaya kailangan natin ng seatbelt. Ayan. When the brakes are applied, seatbelt experts or exert an unbalanced force on the boy. So, ayan. Kasi kung wala siyang seatbelt, tapos biglang tumigil yung kotse, nagalaw pa siya. Diba? Kasi bago ka nag-brake, gumagalaw ka kasama ng kotse. Ngayon nung nag-brake ang kotse, hindi ka naman nag-brake, yung kotse lang. So, dire-diretso yung katawan mo palabas, forward. So, kailangan mo ng seatbelt to counteract that force. Okay? And then, we have to differentiate inertia from mass and weight. Inertia is the ability of an object to resist changes in motion. So, abilidad lang siya. It's the ability. Okay? Hindi siya measurable by number. Hindi siya quantifiable. Walang number na pwedeng makapag-describe sa kanya. Although, may mga numbers na pwedeng uh, mag-suggest kung gaano kalaki or gaano kaliit yung inertia ng isang bagay. That is the mass and the weight. Now, ano ba yung mass? Mass is something that an object has. Mass in kilograms. It tells you how many matter are there. Okay? But weight is a force. That's why it is measured in newtons. Okay? It's dependent on the force of gravity. Because here, weight is mass times gravity. While mass, constant yung mass. Sa kahit saan planeta, pare-pares ang mass mo. Kasi hindi naman nagbabago, hindi ka naman nababawasan. Hindi naman nababawasan yung mga atoms sa katawan mo. So that's mass. Pero kapag nagpapalipat-lipat ka ng planet, depende kasi sa laki at sa bigat ng planet yung gravity. So kapag palipat-lipat ka, magbabago-bago yung weight mo. Okay? So yun yung difference. Mass in kilograms, it's not changing. While your weight, it changes, depends on the gravity, on the force of gravity. So, for the question here, whose mass is greater, the man on Earth or on the moon? Your mass is the same on the moon as it is on Earth. But, your weight is different. Mas magaang ka sa moon. So, yung weight mo sa moon kaysa sa Earth. Kasi, yung gravity sa moon, mababa lang compared sa gravity sa Earth. Pero, yung mass mo, same pa rin. Okay, in kilograms. Yun. For the second law of motion, we have here its definition. Acceleration is produced when an unbalanced force acts on a mass. So you have your force equal to ma, or the net force equal to mass times acceleration. The greater the mass of the object, the greater the amount of force needed to accelerate the object. So, kung gusto mong i-move itong mas malaking bagay na ito, kailangan mo ng great amount of force. Okay? Kasi if you have big mass, you should have also big force. Okay? Examples here. Ayan. So, you have here small mass with a minimum amount of force, that is acceleration. While if you have more force, you have more acceleration. Also, if you have the same amount of force but you have more mass, it means you have less acceleration. So kapag mas malaki o mas mabigat ang mass, mas mababang acceleration. Pero kapag mas maliit ang mass, mas mataas ang acceleration. Kaya yung mga runners, mas mapayat, mas mabilis. And our formula for acceleration is force over mass. The player has to apply more force here para mas mabilis yung ball. Actually, mali yung ball kasi soccer ball to, dapat baseball. Anyway. And then, acceleration of the car is directly proportional to net force applied on it. There. For Newton's third law of motion, yeah, for every action, there is always a reaction of equal and opposite direction or reaction. We call them action and reaction force. So, action-reaction forces do not act on the same object. So, for example, in this picture, the man is pushing the wall 100 newtons, then the wall is also pushing the man 100 newtons back. Here naman, sa picture na to, this person is pushing the barbell upwards, but the barbell is exerting a force of gravity downward, or its weight. So here, other examples, the force of the nail on the hammer, and then the force of the hammer on the nail. Then you'll have this baseball bat to the baseball, and the baseball to the baseball bat. Here naman you have direction of the bullet. The bullet is for going forward, but the recoil of the gun is backwards. Then we have a lot of things here. Ayan, like the magnet and the force of gravity. So we have here some problem solving examples. First, if a net horizontal force of 130 newtons is applied to a person with mass 60 kilograms who is resting on the edge of a swimming pool, what horizontal acceleration is produced? So the answer here is 2.2 meters per second squared. How do we get that? We get the the force equals mass times acceleration. We know that the net force is 130 newtons, and then the mass of the person is 60 kilograms. So to look for the acceleration, we divide 130 divided by 60, and we get 2.2 meters per second squared. That's the acceleration. Okay. Second problem, what magnitude of net force is required to give a 135 kilogram refrigerator an acceleration of magnitude 1.4 meters per second squared? Our answer is 189 newtons. How do we get that? We just simply multiply the mass 135 and the acceleration 1.4 meters per second squared. That is 189 newtons. Lastly, we have number 3 here, a box rests on a frozen pond which serves as a frictionless horizontal surface. If a fisherman applies a horizontal force with magnitude 48 newtons to the box and produces an acceleration of magnitude 3 meters per second squared, what is the mass of the box? So it's mass times acceleration again. We have the net force 48, the acceleration 3. So we divide 48 by 3, we get 16 kilograms. Okay? Last, calculating force, a speedboat pulls a 55 kilogram water skier. The force causes the skier to accelerate at 2 meters per second squared. Calculate the net force that causes this acceleration. So we have information given here. The mass is 55 kilograms, and then the acceleration is 2. So to get the net force, what quantity are you trying to calculate? To get the net force, that will be mass times acceleration. So we multiply 55 times 2 to get 100 newtons, and that is the answer. Thank you for listening. If you have any questions, please message me and expect a response not later than 1 day. Okay, thank you.